to Team 4's final artifact review. Our semester-long project is coming to its conclusion, and with that conclusion comes our final project review. In one sentence, the intelligent bicycle dashcam is a solution for holding reckless drivers accountable for their disregard of cyclist safety. The device takes images of vehicles driving recklessly and uploads them to our mobile application. These images, alongside time and location information, have many use cases that can benefit cyclists on the road. We faced many issues from both the project domain and software engineering in general. Before any code or diagram was conceptualized, we started with requirements. We reference IEEE 830 for verification of requirement quality. While this does not demonstrate any technical challenge, requirements analysis comes with its own complexities. After requirements analysis, we developed prototypes for different aspects of the system, from UML diagrams to convey intent to wireframe UI mocks. Before getting to work coding, we also needed to consider how we wanted to develop the application. Developing for mobile presents unique challenges. We need to support two separate operating systems, each having their own native development environment. This meant two separate code bases that should effectively produce the same solution. On top of that challenge, each operating system has their own configurations and device-specific APIs available, making learning both of them simultaneously confusing. We could have spent this entire semester trying to figure this out, but we researched and chose a development environment that handles everything stated. The rate of development we were able to achieve was built on a lot of engineering. Domain-specific challenges proceeded after the initial planning and design. This project involves wireless communication between devices, central reference for collected data, and user interface support on multiple operating systems. These issues span challenges from low-level serial communication near the hardware to complex cross-platform, backwards compatible user interface configurations. These are the same issues industry giants run into, and there isn't always an obvious or general solution to these problems. The solutions we've come up with to our various issues are documented throughout the project. Although we did not face any unprecedented or uniquely challenging problems within the project domain, we assessed and accounted for a cross-section of engineering challenges that have no obvious solution.
Thank you, Colin. In this section, we're going to talk about the build artifacts that were generated while we formulated a solution to our current design problems at the beginning of this course. First, we're going to start with some of the UML diagrams that were created. Here you can see we have a use case diagram, which was one of the early ideas for how we were going to design the architecture of our system. We also had several activity diagrams going over items that we thought would be very critical to the overall build structure. We have a state diagram of how the protobuf we thought would work at the beginning, and initialization of connection to devices. Following that, we created several research papers to discuss topics that we felt were going to be very important for the overall structure of our design. Here we can see a MVVM breakdown talking about a proposed software architecture for our build. We went over the different components, how it's typically laid out, and these documents provided the basis for the structure of our program today. We also researched Bluetooth and how it would connect. We had to learn about how Bluetooth operated at the low levels, like what GAT was, how we could incorporate it with protobuf, and how we could use it with our development cycle. The research notes proved invaluable for the team to reference back and get answers. We also had a database that we needed to identify the different components of, came up with the entities and the relations tables. This is a breakdown of a first draft of how we were going to have the database work. It was revised over time into the version that it is today. How data was going to work out was based on session, how the sessions and the incidents were structured within the program. We had several ideas, ended up making proposals to the sponsor on what version best referenced his design goals, while they were also for the team to look at and scrutinize decisions made and ensure they were in the best interests of the project overall. When designing the flow of the app, we created a wireframe document that shows how one screen will flow to the next. This was revised over time, but it still forms the baseline for what we have in the final product at this point. This was incredibly helpful as a reference, so we knew know what screens should go where and what screens should link to which screens. So overall, a very helpful document. When designing the build process, we had to look at linters and CI and CD workflow. We had to look into how is static analysis going to work in our project, how we're going to use it, and details like that. This is a document discussing that. Finally, we were looking into using Maps, Google Maps, as a way of showcasing the runs area and highlighting in a user-friendly way how incidents can be located and referenced later. This required using a Google API, which required using Google API keys. So research was needed on how this would work and how this would be used in a development environment to ensure that the key is safe and protected. And finally, we had documentation looking into how protobuf can be used in behavioral patterns, how it can be best utilized in a way that's extensible and easily modifiable. That was very helpful in referencing the end result of what we have for protobuf, which is just recently implemented. Next, we're going to go into the solution, and we're going to talk about the state we're currently at.
Hi, my name is Matthew. This is the IBDC mobile app, a companion app for the Intelligent Bicycle Dashcam device. I'll walk through the app from the user's perspective, covering every completed feature. Starting on the home screen. At the top, you'll see the company's logo and device name. Both persists across every screen in the app. For demonstration purposes, we have simulated a connection to an IBDC device, showing the battery level and current storage usage. Below, that is a photo of the paired device, along with the firmware version and the last sync time. From here, there are three main actions: pair a device, settings, and view ride sessions. Tapping pair device takes you to the Bluetooth setup screen. There's instructional text guiding the user through the pairing process, and a button for scanning nearby devices. Selecting that button opens a modal with available devices, currently 2 hard-coded entries for demonstration purposes, since the Bluetooth isn't yet wired. Selecting the device closes the modal and returns you to the home screen, now updated with that device's information. Tapping settings brings up the settings screen. At the top, there's a placeholder toggle reserved for a future feature. Below that is the app theme selector. There are 2 options, a high contrast theme and the original sponsific theme. Tapping it opens the bottom sheet modal that previews both of the themes visually and indicates which is currently active. Selecting one dismisses the modal and applies the theme app-wide immediately. Next is the sessions per page. This controls how many sessions render at the ride session screen. Below that is the delete data older than. This allows the user to pick a time frame and hit the button below to execute the deletion of data that is older than whatever the user selected above. At the bottom is a debug feature section. This will be removed at production. It lets us seed the database with simulated incidents, so the rest of the app is fully demonstratable. Back on the home screen, tapping Ride Sessions takes you to the session history. Each session represents a continuous ride, displaying the date and start time. Sessions are shown regardless of whether an incident occurred. If nothing was recorded, the session displays "No incident reported" message with an option to delete it since it's likely not needed. If incidents did occur, each one appears as a card within that session. An incident is triggered when the dashcam detects and records a passing vehicle. Each incident card displays a frame from that dashcam footage, but the specific photo is user selected, not automatically assigned. If a photo hasn't been chosen yet, the card shows an exclamation icon and reads "Action Required." The session header also shows a Needs Review badge so that unreviewed incidences stay visible even if they're buried underneath already reviewed ones. Tapping an incident, any incident, reviewed or not, shows an incident detail screen. The user sees their selected dashcam frame at the top. Below, that is a form where you can fill out additional information: license plate number, injury severity, driver's information, whether they stopped or not, vehicle make, model, color, year, plus any extra comments. At the bottom are two actions: choose best photo, and that lets the user swipe through all frames captured by the dashcam during the incident and selects a clean shot to the license plate. Delete incident removes the record entirely. This is useful for cleaning out false positives. Back on the session list, the filter button at the top lets the user narrow sessions by whether incidences exist or whether they still need review. At the bottom, the Next Page button lets you load additional sessions beyond your current page limit. That covers completed functionality in the current build. Thank you.
When looking at the project from a development perspective, our team developed a mobile app built on React Native and Expo. Over the semester, we focused on building up the application structure, as well as connecting all major pieces of functionality together. This included creating the screens, setting up navigation, establishing the database, as well as access to this database. The code base is mainly written in TypeScript using React Native and Expo. This includes the application screens, local schema, DAO files, as well as UI and logic that wraps it all together. We use external libraries such as React Native, Expo, Expo Router, Expo SQLite, as well as several other UI packages. These libraries provided foundation and tools for the app. However, our team wrote application-specific logic for all of it. While the sponsor did not provide code directly, they did provide us with the project need as well as direction. We are also expecting future protobuf integration. That integration is currently being tracked and documented by our team member Colin, who has done extensive research on it. Since the device integration is not fully connected yet, the current version uses mock data to simulate the type of sessions, incidents, and information that will eventually come from the hardware. As mentioned before, all functionality was created and implemented by our group members utilizing the libraries as tools. For example, here on the screen we can see Layout, which sets up the overall application structure, defines navigation, initializes our database, and then we can move on to the main screen, which acts as a dashboard for the application showing device status, battery level, as well as several other navigation options. Write session is where bulk of the logic is, as this screen allows the user to review sessions, filter data, page through results, as well as open specific incidents. All of these implementations are very modular, as that was the design choice we had going into it to make maintainability easier for the future. Moving on to the database, here's where we handled the SQLite connection, as well as initializing the tables. This helped keep database setup separate from the screen logic, which improved organization and allowed a little more maintainability in the long run, especially considering we opted for a DAO-esque pattern, which allowed us to separate the database actions by purpose. So rather than placing the queries inside the screens, operations are organized into DAO files, which are then called. Overall, we feel that we have succeeded in applying the software engineering knowledge we have acquired into this semester. Our approach was very modular by design. We implemented design patterns, kept up incremental development, aimed for maintainability, and by separating the screens from the logic, we created a code base that is easier to understand, update, and expand in the future. Thank you.